Hi everybody, I want to talk a little bit today about implementing a Caesar cipher using ASCII values. Caesar cipher, of course, is a substitution cipher where you get your ciphertext value for each letter by shifting the alphabet up or down a certain number of spaces. So if we start with our ASCII codes, you can see the values run from 0 to 127. We're not actually going to consider extended ASCII or Unicode today. If you wanted to use either one of those code sets with a cipher, a Caesar cipher, the approach would be the same. The calculations are a little bit more complicated, but you shouldn't really have any problem using this same idea. So if we start with just the simple idea of taking the ASCII code and adding an offset, then, for example, let's say we want to shift everything down the alphabet by 5. So we can just add a 5 to whatever that ASCII code happens to be. If we take an example like hello world, of course, we can see that adding a 5 to each of those characters is going to give us a string that we see here, capital M, J, Q, Q, T, %, backslash, T, W, Q, I, ampersand. So that works great, everything's fine. And in fact, if we do that addition to all of the ASCII codes, we can see we get a new code for every character that we need. We have one problem though, and that is that down at the end we have added 5 and our addition has given us invalid results. So for example, there is no ASCII 128 in this basic character set. So if, for example, we were to add curly braces to our hello world message, then we would end up with ASCII values that don't represent any particular character in the character set. So we need to find some way to wrap these values around and make sure that when we get to the end of the alphabet that we go back to the beginning. We can do that, of course, with the modulo operator, also known as the remainder operator, that will let us modulo everything by 128. That way any values larger than 127 will be converted back to 0 and start counting over again. So if we apply that, then we can see that, of course, now we do have valid ASCII characters for each of our last 5 spots. But we still have a little bit of a problem. These characters are valid, but they're not printable. And in fact, about a quarter of the characters in the ASCII character set are considered non-printable characters. While this is not always a problem, if you were to try to feed these characters through a console, like with your Java application, or to a printer, the results would not be something that you would be happy with. So what we want to do is make sure that we can eliminate all the non-printable characters from the output. And the way we're going to do that is we're going to subtract 32 from all of the printable character codes. So starting with the space character, which is number 32, and going on up, we're going to subtract 32 from the value, and then we're going to mod that result by 95 to wrap those values once we've shifted them. And then, of course, at the end, we're going to have to put back that 32 so that we get the characters that we wanted in the first place. If we do that, our final formula is going to be, to get our ciphertext, we're going to take the original ASCII code, subtract 32, add the shift, take the result of that sum, mod by 95, and then add back the original 32 to get back into the space of printable ASCII characters. If we apply that to our original example, we see, of course, now we have an exclamation point and a hashtag to replace the 2 brackets. Everything is legal, everything is printable, all is well. Once again, if we want to decode, we could just change the sign of the offset. The final formula again is pictured here on your screen. I hope this helps. Happy coding.